Recording in progress.
Now we will discuss the remaining part of this. I was telling you, where is my screen now? Okay. Can you see this? Is this visible?
Yeah.
Okay. Yes, I was telling you that in anions, when anions will form, when the atom accept extra electrons, they will have the nuclear charge will be same. And when you compare the nuclear charge with the electron number, like the proton number and electron number, in the anions, the electron number will be more. The number of electrons will be more. So, and when the extra electron will added up, it will be added up in the outermost shell, right? You know this, that whenever there is addition of the electron, that electron always added up in the outermost shell. Okay, it is always added up in the outermost shell. Why is this so? Why it can't
Because
added in the innermost shells or in inner shells?
those are full.
Yeah, because they are full, and the outermost shell, it has some vacancy in it, so the electron will add up in the outermost shell. And when the electron will add up in the outermost shell, obviously there will be repulsion between the electrons of different shells, and like the inner shell electrons will repel the outermost shell electrons, and this is the way the nuclear pull will be weakened, okay, in the negative ions, and the negative ions will have more charge, okay. And the greater the
Okay.
negative charge, the greater the larger the ionic radius. Clear?
Yeah.
Are you clear with this? The more the charge, the more will be the radius. Why is this so?
More the third because the electron shell will be further apart.
You can tell me, it's easy, because
Because the
the same
electron
reason,
shell
just
will
like
be
when you
further.
added one electron, same reason. When you will add two electrons, what will happen?
The ionic radius will increase.
You will firstly you will tell that the electron will add it up in the outermost shell, right? Then what will happen? There will be repulsion between the
Yeah.
innermost electrons, inner shell electrons with the outermost shell electrons. And due to this repulsion, the outermost shell will be farther apart from the central nucleus. And this is how there will be increase in the ionic radius. Clear?
Yeah.
Now can you tell me?
When you add an electron,
Or more than one electron?
the more than one electron,
Hmm.
the repulsion increases,
Hmm. Repulsion
which
will be between
guides between the electrons.
which electrons? The inner electrons and
In
the
the inner
outermost
electrons,
electrons. Yes, because I told you the reason, that in within the same shell there will be no repulsion. The repulsion will be between different shells. Okay, so when you are talking about repulsion, you will tell that there will be repulsion between inner electrons and the outermost shell electrons.
okay,
Clear?
okay, yeah.
Okay, then
Then
when there is repulsion, what will
it
happen?
will it will lead to the electrons being
Sorry.
pushed further apart.
Yes, the outermost shell move further away from the
The innermost shell.
from the nucleus, because nucleus is
from the
your
nucleus.
central point, right?
Yeah.
So you will say this is, I have written it over here. Read this. I have write the outermost electrons move further away from the positively charged nucleus, and there will be less nuclear pull on the electrons. Okay, on the outermost electrons. I must write it over on. If you can't tell me, then it will be difficult for you to write as well. So that's why whenever I ask you, just speak up. Whatever you speak, just speak up.
Okay.
Will be less nuclear pull on the outermost shell electrons. Okay, and the greater the negative charge, the larger the ionic radius. Clear? And
Yeah.
then I will come to this later on. Firstly, let's discuss about the positive charges. Okay, you have this one. I can move this over here. This can be over here. Yes. Okay. Now when we talk about the cations, what happens when cations, how cations will form? Firstly, by losing electron or gaining electron.
Losing electrons.
When atom lose electrons, cations will be formed when atoms lose electrons. Now you have to justify its reason. It will be, we will discuss it in the periodic table, the chapter in which you have to know about the periodicity and the trends, different trends of the electronegativity, shielding effect, different things. So if you are clear at this stage, it will be easier at that time for you. So you must know the reason, how to tell them in the paper, that how the what is the general trend of the cations, the about the ionic radii in across the period and down the group. Now you will have just general trend for the cations, the general trend at this time. Can you suggest me what will happen with the cations? Their size will increase or
The
decrease? Ionic radii
their size will decrease
decrease. Why?
because there's less attention
Yes, you will
between the
say,
electrons.
hmm, the if you what will happen with the nuclear charge?
The nuclear pool will increase. Or like
Hmm?
it will stay remain the same.
Yeah, nuclear charge is same. It will not change. The nuclear charge remains same, but now there are fewer electrons. There are less electrons, so they will undergo. There will be a greater electrostatic force of attraction between those electrons and the nucleus, right? And it will
Yeah.
decrease the ionic radii because now there will be more pull. Now there will be more nuclear pull. So what we can suggest the reason is over here is that by losing electrons, fewer electrons left behind with same nuclear charge. Okay, this will undergo a greater electrostatic force of attraction. Okay, a greater electrostatic force of attraction or greater nuclear pull. Clear?
Okay. Yeah.
Or greater nuclear pull. Okay, and similar is the case over here. The more the positive charge, the smaller the ionic radius. Clear?
Yeah.
So, can you now explain me what is the ionic radii when an atom loses electron?
When atom loses electrons,
Mm-hmm. Yes.
there will be less electrons left
Yes.
with the same nuclear charge.
Mm-hmm.
So since there's fewer electrons, they experience the electrostatic force.
Of attraction, or you can say there will be a greater nuclear pull. Both are acceptable.
Will be different.
I will tell you why I have written about the electrostatic force. Firstly, complete your statement, then I will tell you.
There's a greater nuclear force,
Mm-hmm.
so they'll be closer together,
Mm-hmm.
so the radius will be less. Okay.
Can you hear me?
I can hear you now. I can hear you.
Okay. I don't know how my AirPods were connected to this, and I don't connect AirPods usually because there is much more distortion due to that. Okay, what you were saying?
I was saying that because there's a greater nuclear force, um, the electron shells will be closer together. That's why the radius will be less.
Okay. And if we, like for example, let's take the example of over here. We can take the example of sodium. This is a general example. You have the sodium, that is sodium 11 and 23. Let me confirm this. Sodium, yeah, 11 and 23. Okay, it has lose an electron. Sodium plus one electron is lost. Now can you tell me what is the A is 23, Z is same. What is electron number now?
The electron number
For this,
is your screen moving?
what will be the
Okay,
electron
now
number for this example? Like you have sodium, and
the electron
it has lose an electron now.
27.
Hmm.
If it loses an electron,
Mm-hmm.
and then gains it again,
Sorry, what you are saying?
it will be 10.
Yes, 10 electrons. There will be 10 electrons. So you see now you have more protons. You have now more protons. So there will be a greater nuclear pull. Okay, so there will be a greater nuclear pull. So this is how, if you don't understand things by just reading the theory, you can just solve these examples, and you can compare the proton number and electron number. And when you will see in the cations, always you will see in the cations the electron number will be less as compared to the protons. That is why we say the cations, or they have an overall positive charge. Why they have an overall positive charge? Because now if you compare these two, now if you compare this one and this one, the proton, there is one extra proton, right? There is one extra proton, isn't it? If you compare these two, this is 10 electron and this is 11 proton. What is extra over here?
The proton.
Yes, that is why it has one positive charge. Clear? And similarly, if you see this
Yeah,
example, if you see this example, you compare proton number and electron. What is more? Which one is having more value?
the electron.
The electron is having more value. So that is why there is, and one electron is more, right? So it is written as like this, negative. Okay, clear?
Yeah,
Okay. Now I am giving you an example of two. This was an example of just one electron. Now we can take an example of two. Magnesium. Okay, that is 24 and 12. This will be magnesium 2 plus 2 electrons. Okay, I have put these brackets to just separate it from the answer. What is A now for magnesium?
it's 10.
Hmm?
For aluminum, it's 24.
It's
24.
24. Right. What is Z, the proton number?
12.
12. What is electron number now?
10.
10 electrons. You see, now electrons are 10 and the protons are 12. Which quantity is more? Proton, proton
The
number or electron
proton.
number?
The proton.
And how many protons are more if you compare these two?
There's 2 more.
Two more. That's why it is 2 plus. Clear?
Yeah.
Okay. So this is how we write these things. And yeah, if you see this, over here, this in this diagram, this is the original lithium, the gray color, and this lithium ion is with red color. Okay, so you see now the lithium ions radii is reduced. It is clearly visible. Are you getting this diagram? They have shown in the same image, they have shown the lithium atom as well as the lithium ion. This is the ion. The red part is ion. Okay, the red one is ion.
Yeah.
This one is an ion, lithium ion. And you see, this is, its size is less as compared to the lithium atom. And when you go over this side, what is happening? From lithium to beryllium, what is happening? If you just talk about the atomic radii, what trend we have discussed in the atomic radii? Across the period,
The
what
greater
happens?
the positive charge,
Across the period, what happens?
the ionic radius decreases.
Ionic. No, I am not saying ionic radius. I am talking about the atomic radius, the lithium, beryllium, boron. atom, what happens at the atomic level?
Um,
Atomic radii. Mm-hmm.
atomic area
We have discussed atomic radii.
is
This one, across the period.
across the across the period.
Hmm.
It will increase.
What is this? Across the
Decrease.
period, it decreases. Atomic radii decreases across the period, isn't it?
Yeah.
So this is what I am saying you. If you see this diagram, this atomic radii, the gray color. You see this gray color part? This is decreasing. This is decreasing. Over here, this is decreased now. This is decreased now. Clear?
Yeah.
And when you see the oxygen atom, if you see the oxygen atom, this is the gray part. This part, this. You see this? This is oxygen atom. Okay. So oxygen atom has much less radii than boron. So this is right. We have discussed it that across the period, the radii will decrease. Atomic radii will decrease. I am talking about atomic radii. I am not talking about the ionic radii. Clear? Atomic radii decreases across the period, and we have discussed the reason in
Yeah.
detail. Now, when we talk about the ionic radii of this diagram, if you check this diagram, the ions, these are the red ions. This one is having much bigger size, right? The ion. Now, the ionic radii is
Yeah.
decreased, and it has much reduced ionic radii. Why? Why is this so? There are two reasons.
Because of nuclear force.
Huh?
Because of the electron explosion.
Yeah, because if you
Yeah.
see in this just one electron is lost. This is lithium plus one. Okay, in this just one electron is lost.
Yeah.
Okay, but in the second diagram, if you see for beryllium, there are two electrons are being lost. And why two electrons are being lost? Because it belongs to the group number 2. Okay, so it will lose two electrons
Yeah.
to stabilize itself. You know the octet and duplet rule, of completing the valence shell.
Mm.
Okay, okay, we will discuss that. At this stage, you must just understand this, that beryllium, it belongs to group number 2. That is why it will lose two electrons. Okay, beryllium, magnesium, calcium, they will lose two electrons, and the group number 1 electrons will they will lose just one electron. Group 3 lose three electrons. Clear?
Yeah.
So this is the reason. In this, it just lose one electron. Lithium just lose one electron. That is why it has much bigger size as compared to the beryllium. Beryllium lost two electrons. That's why its size is reduced, and the boron reduced three. Lose it loses three electrons. That's why its size is much more reduced. Okay, this was for cations. One more thing: don't compare cation and anion in the same manner. Like, I just gave you the comparison of these three, okay, at this time. Now I am giving you the
Yeah.
comparison of the anions. Okay, don't compare anions and cations together, you will be get confused. Okay, now if you see anions, firstly, the atomic level, you see in the atomic level we have discussed that across the period the atomic radii decreases. But now when we talk about the atomic radii, the anions, this is anion. What was the atomic radii of the anion? What happens with the atomic radii of the anion?
The atomic release for the ion is when the positive charge increases, it decreases along the group.
Sorry, your voice, there is so much distortion. I don't know why. I can't hear you.
It's because I'm wearing something. Can you hear me now?
Yes.
What was your question?
I am asking what is the uh, ionic radii of the anion. Does the ionic radii of the anion increases or decreases from the atom? When we make an anion from the atom, what is the general trend of the ionic radii?
It increases
It increases in the anions. Why it increases?
because
Hmm?
the negative charge of the atom.
Yes, because the electrons are added up in the outermost shell and there is repulsion in between the inner electrons and the outermost shell electrons. So the outermost shell electrons will be farther apart from the nucleus and there will be less nuclear pull on the outermost shell electrons. You must know these 3-4 lines. Okay, these are the main reasons. And you must know how to
Okay.
put this information in the paper, in the P2. Okay?
Okay.
Yes. Now if you see, this is the 71 is, they have mentioned the 71 nanometer is the its original radii of the atom, and in the ion it is increased by 119. Similar is the trend over here. Okay, in this, if you see this, for the, yeah, now we can talk about the groups. If we down the group, we have discussed about the period. Now we will discuss about the group. If you see the group, down the group, what is the trend in the first group? About the atomic radii. I am not talking about the ionic radii. Atomic radii. Atomic radii means this one, this one. Okay, whenever I am
Yeah.
talking about atomic radii, you must know that I am talking about a neutral species. Clear?
Yeah. Is it the same for the?
Mm-hmm. Same for, we have discussed it.
It's the same
I
for
think you
every
need to
element?
eat something again, right?
No, I can't hear you guys.
Down the group, if you see, this is the atomic radii. This was the part of the atomic radii, and in atomic radii, I told you this. Down the group, what happens down the group?
And down the group, the atomic radius increases.
Hmm?
Increases
Yes. Why it will increase?
because there are more electron shells.
Yes, because the shells are increased, because there are more shells now. There are more shells now. Okay, and due to the more shells, what will happen now? The inner shell electrons will repel the outer shell
Okay,
electrons.
cool.
Yes. Now there will be less nuclear pull. Okay, nuclear pull will be less, and there will be less effect of the nucleus on the outermost shell electrons. So down the group, the atomic radii increases. Clear?
Yeah.
Okay. And what about now? Tell me about the ionic radii, the cationic radii, because now we are talking about the cations. Hmm? Down the group,
What? What do you
what
mean?
happens? Down the group, what happens with the cations? First, you just tell me about the
The
cations. When you have an atom, and that like atom, you are converting it into cation. How cation will form from the atom? Hmm?
pattern will form.
Sorry,
Can you repeat that? I can't hear you.
sorry, I can't hear you. What you are saying?
I can't hear you.
I don't know why is this so. Your voice is so low. Are you using any of the hearing tools like hand-free or AirPods?
I'm using AirPods.
I think that's why. Because in the previous recording, your voice was clear in the previous. link. Now I can't hear you properly. Your questions, I can't hear you.
Yeah, wait. 1 second.
That's why
Can you hear me now?
I am also not using AirPods, just because by using that voice always there is less volume of the voice. I don't know why it happens.
Yeah, but like when I was using it,
Hmm.
the voice was like I could hear myself from the other side.
Now,
I can still hear it, but it's not that loud.
okay. Okay, I was asking
And it
you,
was like picking up all the background sound.
is there doubling of the voice? Your voice is doubled.
Yeah,
Is it? It is happening continuously.
yeah, hmm, really.
Okay, if I mute my mic and then you speak, then tell me. Uh,
I can't hear anything now.
no, I just muted myself so that you can check, is this due to my mic or it's just from your side.
Yeah, it's because of your voice.
I am just
Because I
muting
hear
for
my
1 minute. You can speak and then you can check.
yeah, I can't hear anything now. Like, because it's coming from your side.
Is there echo now when I mute myself? Is there still echo?
No, there's no.
So it happens when the mics from both sides is open. It happens then. It happens
Yeah.
generally in the meetings when the mics are open
Can
from the
you
both
can
side.
you can you hear your voice from my side?
No, I am not hearing from your side. But your voice is too low. But in the previous meeting, your voice was clear.
That's because I was in rain.
I am not getting any echo.
Even in the first meeting you couldn't hear.
Your voice is too low.
In the first meeting, did you hear an echo?
No, it was clear. I just watched the recording to check the voice and all. That was good. Your voice was clear. Even though there was
Yeah, but
your father's voice as well, because there was background voice as well. Uh,
that was my brother.
hmm.
Because that's why I was wearing headphones because it's not
Yeah,
my family's
I
voice.
can understand this, but I don't know by when you use those aids, I can't hear you. What can we do? You can check the setting of your AirPods, right? Check the
Yeah.
setting. Maybe there is some problem with the setting. Maybe because otherwise there will be issue. Okay. Yeah. I was asking you this about the cations. What is the trend?
Down the stairs.
Yes, just first tell the trend of the cations. How you make the cation from the atom, and then what is the
Cations.
ionic radii of the cation?
Cations are formed by the loss of electrons.
Sorry.
Cations are formed from the loss of electrons.
Okay. And what about their radii?
The radii increases as they lose more electrons.
As they
Lose more electrons as their positive charge increases.
yes. Uh, and when they lose electron, what happens?
When they lose electrons,
Mm-hmm.
there are fewer electrons, then the nuclear charge it remains the same.
Nuclear charge?
So it remains the same.
Yes.
So as so the electrons feel the greater the electrons feel the greater nuclear pull,
Hmm.
and so
There's more
they're
nuclear
closer
pull.
together. So the cells are closer together,
Hmm.
and so the diameter. that ion also decreases.
Yes, because now there is more electrostatic force of attraction, right?
Yeah,
Now there is more force, electrostatic force of attraction, and there is more nuclear pull. The outermost electrons, they will be they will be attracted toward nucleus with a more stronger force, and that is why in the cation the ionic radii decreases, and the greater the charge on the cation, the smaller the radii will be. Clear?
yeah.
Okay. And what is the trend down the group for the cations? If you see this red ball, this red diagram, what is the trend of the cation down
Down
the
the
group?
group, it gets
Hmm?
it's getting larger.
It increases, right? It is simply just like the atomic radii. Okay, the trend is same, just like the atomic radii for the across the period and down the group. The trend for ionic radii will also be same, but for ionic radii, firstly you will tell that how ionic radii is formed, that particular anion or cation, how that radii is formed. And in anion in general, when we talk about anion, what happens with its size, does the size increases or decreases? And when we talk about the cation, the size is increased or decreased. You will tell firstly this in the general context, and then if they ask you like the trend across the period or down the group, so you must know that across the period it decreases for the cation, and it will increase down the group. Clear?
Yeah,
But for anion, if you see, for the anions, you can have yeah, it is also decreasing for anions down across the period. For anion, if you see, this is 126 and this is 119. Similarly, down the group it will increase. Across the period it will decrease. Down the group it will increase. This is an example of the period number 3, the ionic radii. Just like I gave you the example of atomic radii, the atomic radii. Now you have an example of the ionic radii. So you see the period number 3. In period number 3, you have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chloride, and argon. So over here in the period number 3, this is the period number 3. The sodium, magnesium, aluminium, sulfur, chloride. Okay. If you see this, this is the graph. What is the general trend over here? Hmm? What is the general
the
trend?
general trend here,
Sorry?
it's first it's decreasing.
It is increasing or decreasing? Firstly, it is decreasing. Then there is
Yeah,
an anomalous behavior with this phosphorus. We will discuss this in some other chapter, in some other topic. But at this stage, you can ignore this. Okay, you can ignore this at this time, and you see this from here till here. This is decreasing. So this is decreasing across the
yeah,
period. You know the ionic radii from here, from sodium, magnesium, aluminum, silicon till silicon, it will be decreased. Then for phosphorus it will increase, and again it will start decreasing. Clear?
yeah.
Okay. So yes, we are done with this, with the atomic radii and the ionic radii. We are done with the section 1.1, and in the next class we will do the isotopes. We have done all these things, the atomic radii, ionic radii. You see, they have mentioned the state and explain